Hello everyone. In this video, we will solve some questions based on the topic of week 9. So the first topic is random variable. So we know that there are two types of random variable, discrete random variable and continuous random variable. So a discrete random variable is a variable which has possible values that are discrete points along with the real line. So discrete random variable basically takes discrete or distinct values on the real line, and it involves the counting, suppose the number of people in a household, or the number of balls in a box, or number of people in a classroom, etc. Okay, and the second is continuous random variable. So continuous random variable takes all the possible values in the interval. Okay, and continuous random variable involves measuring. For example, amount of tea in a glass or height or weight of a person is also measured and not counted. Okay. Now the question number 1 is, consider the following. A. Number of spelling mistakes in a report. B. Time taken by a person to write an exam. C. Weight of a person. So which of the following is a discrete random variable? Now here you can see that the first option is number of spelling mistake in a report. So we can see that number of spelling mistake will be a discrete random variable, because number of spelling mistakes could be like 1 or 2 or 3. So it will be taking the discrete values on the real line. So option number A will be correct. And the time taken by a person to write an exam. So suppose the exam is of an 3 hour. Okay, suppose this is 0 and this is 3. So the time taken by a person could be any value in this interval. So time taken by a person will be a continuous random variable. Okay, now weight of a person. So weight is also a continuous random variable. So weight of a person can be like 56 kg or 56.5 kg, or it can take any value in the range. Okay, so it is also a continuous random variable. So only option A is correct here. Now the next is probability mass function, PMF. So suppose x is a discrete random variable, and suppose it has n possible values which are x1, x2, x3 up to xn. Now the PMF or probability mass function for the random variable x is defined as the probability that the random variable x is taking value small xi. Okay, and there are two properties for the PMF. First one is that probability at every point or at every value that x is taking should be greater than or equal to 0. And the second one is that the summation of all the probabilities over the range of x should be equal to 1. Now our question number 2 is, let x is a discrete random variable, takes the value 0, 1, 2, 3 and so on. So by applying the properties of PMF, is 5 by 6, 1 by 6 to the power x is a PMF. So we have to find out that this term is a PMF or not. So there are two properties of PMF. Okay, first of all, that the probabilities should be greater than or equal to 0, and the second one is that the summation of all the probabilities should be equal to 1. Okay, so here we can see that here x is taking value 0, 1, 2, 3 up to so on. So if in this term we put the value of x, then this quantity will always be greater than or equal to 0. Okay, the first property is satisfied. Now we have to check for the second property. So here we will find the sum and we will check whether it is equal to 1 or not. So here this term is taken out of the summation. Now we have to take sum of this quantity. Now it will be 1 by 6 to the power 0 plus 1 by 6 to the power 1 plus 1 by 6 to the power 2 and so on. So we can see that it is a geometric series. Okay, suppose we have a geometric series like this. So this is an infinite geometric series. So the sum will be equal to a divided by 1 minus r, where a is the first term of the series and r is the common ratio. So here we can see that in this series, the first term is equal to 1. Okay, so this is our 1. Now the common ratio is 1 by 6. Okay, so 1 minus 1 by 6. Okay, now we will solve this term and we can see that the summation is equal to 1. So here both of the properties are satisfied. So we can say that this is a valid PMF. Now the next question is, a random variable x has the following probability mass function. So this is the PMF given. Now the question is, find the value of k. So we know that this is a valid PMF. So from the property of PMF, the summation of all the probabilities should be equal to 1. So now here we can see that we have taken the summation of probabilities. It should be equal to 1. Now we have put the values here. Okay, and when we solve it, we will get our quadratic equation, which is 10k square plus 9k minus 1. And after solving this quadratic equation, the value of k will be equal to 1 by 10 and k is equal to minus 1. So we can see that probabilities can never be negative. So k is equal to minus 1 is not possible. So the value of k will be equal to 1 by 10, or which is equal to 0.1. Next question. A random variable x has the following PMF. This is the PMF. Now what is the value of probability x is less than 6? So first of all, we need to find out the value of k here, which we have already calculated in the previous question. Now the probability that x is less than 6, which means x will be taking the value 0, 1, 2, 3, 4 and 5. Up to 5 we have to find the probability. Now here we have put the values of the probabilities at the different points like 0, 1, 2, 3, 4 up to 5. And when you solve it, the answer will be 0.81. Next question. A random variable x has the following PMF. Okay, now we have to calculate the probability that x is taking values between 0 and 5. Okay, so we need to find out the value of k here, which we have already calculated. Okay, so x is taking values between 0 and 5. So the x will be taking value 1, 2, 3 and 4. Now we have put the values of the corresponding probabilities. Now after solving it, we will get this probability as 0.8. Question number 4. Naman has to give 3 mock tests. The probability that he will not give any mock is 1 by 8. The probability that he will give 1, 2 and 3 mock tests are 3 by 8, 3 by 8 and 1 by 8 respectively. Let x be a discrete random variable which represents the number of mock tests given by Naman. Now the question is, what is the probability that he will give at least 2 mock tests? Okay. Now here we can see that Naman has to give 3 mock tests, okay, and the random variable x is a discrete random variable which is representing the number of mock tests given by Naman, okay. So the maximum value that x can take will be 3, okay. So either the Naman is giving no test, or he is giving 1 test or 2 tests, or maximum 3 tests he can take, okay. And their probabilities is also given. If he will not give any mock test, which is x is equal to 0, so this probability is 1 by 8. So this is 1 by 8 here. And when he will give 1, 2 and 3 mock tests, it is 3 by 8, 3 by 8 and 1 by 8. So this will be the probability mass function for the random variable x. Now we have to find that we have to find the probability that he will give at least 2 mock tests, okay. So which is that we have to find probability that x is greater than or equal to 2, which will be equal to probability that x is equal to 2 plus x is equal to 3, because the maximum that x can take here is 3, okay. Now for x is equal to 2, the probability is 3 by 8, and for x is equal to 3, probability is 1 by 8, okay. Now we will take the sum, so the answer will be 0.5. Now the next thing is cumulative distribution function, or CDF. So we know that the formula for CDF is fx is equal to probability that random variable x is taking value less than or equal to x. So basically our cumulative distribution function accumulates the probability up to a certain point, which is x here. Now there are some properties of CDF. So it takes value in the interval 0 to 1. Okay, so the minimum value that the CDF can take is 0 and the maximum it can take is 1. Okay, and suppose the next property is that if x1 is any point in x and x2 is another point on x, so x1 is less than or equal to x, so the CDF and at point x1 will also be less than or equal to CDF at point x2, because CDF is always a non-decreasing function. Now the question number 5 is, let x be a discrete random variable with the following probability distribution. So here is the distribution of x given. Now calculate the value of f3. So we have to find out the value of CDF at point 3. So first of all, we need to find out the value of K here, which we can find by using the properties of CDF. So the summation of probabilities should be equal to 1. So the probabilities here are 1 by 4, 4k, k and 1 by 8. So their sum should be equal to 1, right? So from here we have find out the value of k, which is equal to 0.125. Now we will find out the value of CDF at point 3, which we can write it as probability that x is less than or equal to 3. So we have to find that probability that x is equal to 1 plus probability at point 2 plus probability at point 3. Okay, so which we are given is 1 by 4, 4k and k. Okay, so now we will put the value of k here and we will get the CDF at point 3, which is equal to 0.875. Now question number 6. If probability that x is taking value small x, it is equal to x by 16 and x is taking value 4, 5, minus 1 and 8. Now we have to check whether it is a PMF or not. So we can see that at point x is equal to minus 1, when the x is taking value minus 1, then the probability will be equal to minus 1 divided by 16. So here we can see that the probability is being negative, which is not possible. So we can conclude that this will not be a valid PMF. So no is correct. Question number 7. From a vessel containing 4 black and 5 white balls, 4 balls are transferred into an empty vessel. Let y be a random variable that represents the number of black balls which are transferred. Now, what value of the random variable will have the maximum probability? So here we have a vessel which contains 4 black balls and 5 white balls, and we are transferring 4 balls from this vessel. So we can see that maybe we are transferring 0 black balls and 4 white balls, or maybe 1 black balls and 3 white balls out of the total 4 balls that we are transferring. Maybe 2 black balls and 2 white balls, or maybe 3 black balls and 1 white ball, or maybe 4 black balls and 0 white balls out of the total 4 balls that are transferred. Now we have to find the value of the random variable y for which the probability is maximum. Now here y is representing the number of black balls. Okay, so the number of black balls could be either 0 or 1 or 2 or 3 or 4. So the random variable will be taking values 0, 1, 2, 3 and 4. Now for each point we will calculate the probability. So first of all, for 0, so out of the 9 total balls, we are transferring 4 balls, okay? And y equals to 0 means we are transferring 0 black ball, okay? So total black balls are 4 here. So 0 balls, which means out of the 5 white ball, we are transferring the 4 balls, okay? This probability. So it will be equal to 0.039. Now for y is equal to 1. So out of the 4 black balls, we are transferring 1 white ball, 1 black ball, and out of the 5 white ball, we are transferring 3 white ball, and total out of 9, we are transferring 4 balls. Okay, so it will be equal to 0.317. Similarly, we can find for 2, 3, and 4 also, which will be this. Now here we can see that the probability is maximum for y is equal to 2. When the random variable is taking value 2, then the random variable having the maximum probability. So the y is equal to 2 will be the correct answer.